We were taking a look last time at section 11.3. We had talked about a variety of different descriptions of comparing angles. Real quick, let's just run through the names of those and remind you what they were. Complementary and supplementary had to do with two angles adding up to 90 for complementary, adding up to 180 for supplementary. We had interior angles that lie between parallel lines and exterior on the outside of the parallel lines. And then we had alternate interior and alternate exterior, which had to do with being on the inside or the outside, but on the opposite sides of the transversal. And then corresponding angles, I think, was our last one. And corresponding means they're in the same location as they're centered around the transversal. And then we had this wonderful fact, it's a theorem, we could prove it, that says what happens if corresponding angles are congruent, and we have all these features, which is wonderful, but it's actually true that if we have any one of those features, that any of the other statements hold. So these are like equivalent statements. Knowing any one of these guarantees the other three. All right, so what we're going to talk about next is constructing parallel lines using a triangle. We're going to talk about lots of ways to construct parallel lines and even more into chapter 12, but this one's kind of a cool one. So if you take a look, this is explanations also on page 690 or 659 in your book, so they have wonderful pictures there and you can take a look at that later, but let me kind of describe what's going on. All right, so we're going to we'll do a little bit of writing on our screen here. Let M be a line. And point P, I'll write point 2. Point P not on M. Okay, so let's draw the picture of what I've already described. We've got a line, and we've got a point P not on it. So here's point P, here's line M. So far, so good. I've probably drawn it in such a way that when I start sketching other things, this is not going to be very good. Maybe I should move my point P just a little bit closer, just for the sake of it. It's a line, yeah. I mean, it has ray components, but yeah, it's a line. I'll put my lines on the end of it. All right, so we're going to create triangle ABC. Where one side lies on M. One side of the triangle lies on line M. Wondering if, trying to think how I did it last semester. Let me write the rest of it down and then we'll do it together. Okay, so we're going to create this triangle, lies on M. We're going to lie a ruler. I think it's lay. That was bad English. Lay a ruler. Along side, and the way I'll draw it is I'll make it side AC, okay? Alongside AC, and slide triangle ABC along the ruler until AB intersects C. Not C, intersects P. This will be a line L parallel to M through P. By creating congruent corresponding angles. All right, so we need a triangle that, let me see if I can create my triangle very well. I said AB was going to be on, AC was off. A different color. Help if my picture matched my diagram I already had. Okay, we'll try and see if that will work. All right, so
what rule says that it has to be on that side?
there's no rule that says it has to be on that side. That's why I was trying to decide how I wanted to draw it to make use of my space best. Oops. All right. I'm going to start my picture over. Let's do that. Here's point P. And we're going to make our line right here. Oops. All right. I'm going to draw my triangle down here. I said I was going to do a different color. Let's do that. That'll work. And then this line that's on there is line AB, or segment AB. And C is off. Okay. Here's, I had a ruler in here. Well, it's not a ruler, but it'll work. Okay. What we're going to do is we're going to extend line AC with the ruler like this. Okay? So you're just going to extend this line, continuing it on upward, okay? I think that's pretty good. And the idea then is that if I have my triangle, this triangle should be able to slide up the ruler, okay? You picture that? The triangle just sliding along the side of the ruler. So if you were to create, I don't know, like a separate sheet of paper that was the same size as the triangle so you could actually physically move the triangle, that would be what you're doing. And you're moving it up until it actually hits point P with the side AB that was horizontal down here. Right here. So this is going to slide up until we intersect point P. So my picture ends up crossing eventually up here. Like this. So this is now, when we move things, we often put a prime on them. So this is A prime, B prime, C prime. It's the new location of ABC. And this line where it crosses P is the parallel line that we had before. So this line, whoops, let me try that again. There we go. Would be parallel, and we called it line L in the description. All right. Okay. We're going to be doing a lot more with constructing parallel lines later on. This was one that was kind of cool here. And the reason these are parallel, I mean, you kind of got the feeling like it makes sense that they are, but the real reason that it is, and it references it right here, is that this angle and this angle are the same, right? And we had a theorem back there just a minute ago that said if we have corresponding congruent angles, we have parallel lines, and vice versa. It was that 4-part where I said these are all congruent to each other. That's where it is. And so we have, because we have these congruent angles, we have parallel lines from here. All right, we are going to do a short activity. It's very brief. I hope you guys have some scratch paper. Here's what we're going to do first. Okay, write this in. The sum of the measures of the interior angles of a triangle is 180 degrees. And you guys know that to be true. If I asked you that before we filled this in, you could have filled this line in no problem on yourself. Grab a piece of scratch paper out of your book. Lines, no lines, doesn't matter. I don't want you to make it terribly, terribly small, tiny little triangle because it's going to make it harder for you to work with. But grab a piece of scratch paper. And I should have brought scissors, and I didn't. Okay? So what I'd like for you to do is I'd like for you to fold 3 sides to make a triangle. I don't want it to be just a 90-degree angle because it almost feels like cheating because this really should work with any triangle. So fold along one side, right? Score it really good with your nails or whatever. Tear it, okay? And try to tear it as straight as you can. Use the corner of your desk if you'd like, whatever it takes. That wasn't a good idea. The way I just did it didn't work. All right, so create yourself a triangle that, I don't know, hopefully doesn't have a 90-degree side, a 90-degree angle. Mine was awful. That didn't work at all. Okay, if you want, you can fold it instead of whatever, but just create yourself a triangle that's not got any 90-degree angles.
I can do without 90 degrees if the paper's like on it.
I just don't make the corner one of the corners. Okay, so just tear it so that it's not one of your corners. I mean, some of you can make a 90-degree triangle. It's not that nobody can. It just, if all of you do, then it starts to feel like I'm cheating. And I'm not cheating. I promise it works without 90-degree angles. So I want you to be convinced that it does, in fact, work without 90-degree angles. Yeah, I know. I should have brought. And I think I still ended up somehow with a 90-degree angle by accident. How did I do that?
If that's what I was running into, like it's hard not to make it 90 degrees.
Yeah, it almost looks like you do have a 90-degree one. Nobody like happens to have scissors, do you? Oh, Emily's gonna share her scissors with everybody.
I mean, does that have to be perfect?
No. But the better it is, the more perfect it is, the more convincing my argument's going to be. All right, so Emily's going to pass her scissors to anybody that needs them, right?
Oh, I know what you did. Yeah. My turn.
You've got a 90-degree one.
I got you.
Just
figure out how to not make one.
have to promise me that you understand that it doesn't matter if it's 90 degrees. That one will.
I don't have one, right? That's right. Just make sure it
Cut a
matches
random
like the
triangle.
other corner.
That should work. Yeah, you should be okay. So I agree.
A little small, but you know, I just
Yeah, these sides look good. I just don't, if you make them too tiny, it starts to be like, I can't just deal with this. It's too tiny.
angle it more.
Okay. There are scissors. Does anybody else happen to have scissors?
I have scissors.
Oh, Megan's got scissors too.
Yeah, but it's not very perfect. I can't get rid of my
It's not a set.
Look at it. I like from like this.
Yours is making it really difficult, Jasmine, for you to figure out that this is a true argument. Okay, there's some scissors coming around. Grab some if you'd like. After you've decided your triangle's straight enough on the edges, I want you to label the angles. Just write 1, 2, 3, A, B, C, X, Y, Z, whatever you want. Just label them somehow, okay? So inside of each of the corners, if you will, the vertices, there should be an angle or a letter or a number marking it. Okay? After you have marked them, you're going to tear your triangle into 3 pieces. Each of your angles is going to be one of the pieces. Okay? I know. Tearing pieces of paper is so sad.
3 pieces.
Okay, yeah, so you should have 3 pieces. Each piece has one of the angle markings that you just created.
Doesn't matter the shape.
Nope, doesn't make any difference. Nope. I mean, don't tear along the angle themselves, otherwise you'll tear your number or your letter in half, which is exactly what you don't want to do. So you have 3 pieces. The edges that were supposed to be straight, that we were hoping to achieve straightness with the scissors and so forth, I want you to correspond them. So the vertices, so here's my 2 and here's my 3, they should match up. So the vertices are together at a single point, and then do the same thing with your third point. Okay?
Wait, so how are we supposed to tear them? I'm really confused.
Just like this. Oh, I think I got it. Huh,
No,
that's a
see,
straight
I
line,
couldn't
that's
find
weird.
Okay, Emily's got it.
Okay, wait.
What would you put like this?
Just put all A, B, C have to go together.
Put it around.
Good. Match up together, so match all your numbers. You got it, that's fine.
I don't know what I'm doing. Just like, yeah, that way.
Get two corners off. So it's like the 3 corners.
That's awesome.
It was like 10.
I know, yeah.
You have it?
It'll be fun.
Do you know how first one you were about? Okay, I really thought you were.
No, I don't think
That would be a rough start.
Yeah, I know.
I'm so
Okay, this is not what we want. Because the B is nowhere near the C and the A. I think it's got to be beside the A. Yeah, the letters have to be beside each other.
It's okay, I didn't get you.
1, 2, 3, beside it. One, beside it.
Yeah, it'll be fun. And I'm pretty sure we can be everybody and somebody.
Yeah, that's right.
Yeah.
Teams like come and like they like they're not and then they still work.
Can you please all dress like as nerdy as possible? Like please tuck your shirts in and like pull them up.
If we make it to the championship.
Okay, deal. Are they basketball shorts? You're gonna wear basketball shorts? I told my sister string them around your neck. You're gonna be like really high.
Okay. I think everybody's picture looks right now. What does it look like? It looks like when you match those corners up, they create a straight line, an edge. And the better our triangles were to begin with, the easier it's to see that they create that straight edge. And that straight line would be a straight angle, and straight angles have how many degrees? 180. And therefore your triangle does as well. Because the 3 angles, when they're disassembled from the triangle, all match up and form a straight line. Right? That's the why. So where it says, but why here, you can fill it in. Write a description, a short description for yourself of what you did with your triangle's angles. Okay? Took a triangle, you tore apart the corners, and the corners, when they're pieced back together, formed a straight angle. Right? And a straight angle has 180 degrees.
Can I do my homework on this paper?
That's probably not a good idea. I don't think out of space.
You're right, it's not professional.
This is a visual picture of what you just did, roughly. Right? Formed them back together and you create a straight angle. Okay, so that's great. Triangles have 180 degrees, and we can do this by disassembling them this way. What about a quadrilateral? What about a pentagon? What about a hexagon? Well, you can actually break apart each one of these objects into triangles. Okay? So if I take the first one that I've pictured here, it's a random quadrilateral because I don't want you to think that it needs to be a square or a rectangle, although it'd be much easier to create a square or rectangle, right? If I take this quadrilateral, random quadrilateral, and I break it apart right here into two triangles, each triangle would have 180 degrees, and if I add those two together, how many angles, or what is the degree measure inside of a quadrilateral? 360, because it's 180 plus 180. Now you have to be careful once you get any larger than a quadrilateral that when you are tearing them into the triangles, you're tearing them from the same vertex. Do you see how my triangles are drawn from the same vertex here? It kind of matters, and it matters more when we get to even bigger shapes. So as long as I pick one vertex to create my triangles from, this will work. So I created 3 triangles. So 3 triangles gives me 3 times 180 for a total of 540. Yep. So that's a pentagon. So what happens for a hexagon? You tell me. Yeah, times 4. Which is what? 720. So the question is, do you see a pattern? The number of triangles, how is the number of triangles in the shape related to the shape itself? Well, we're going to multiply by the 180 later, but I want to know just how the number of triangles relates to the shape.
The sides minus 2.
It's the sides minus 2. When I had a pentagon, which is 5 sides, I had 3 triangles. I have a hexagon is 6 sides, I have 4 triangles. Quadrilateral is 4 sides, I had 2 triangles. So the number of triangles is the number of sides minus 2. And if we call the number of sides n, for short, n for number of sides, then what do we do with that number of sides? You guys just told me a minute ago. We multiply that by 180. So the way that we can find the number of degrees on the inside of a triangle is n minus 2 times 180. You don't have to break them apart into triangles every time. Could you? Sure. But you don't need to because we've established a pattern for the future. So what would we do if we had a shape with 37 sides? Because I don't want to create a 37-sided shape. We would do 35, that's right, times 180. Yeah, the minus 2 we already did. So 37 minus the 2 gave me the 35. Ooh, that's big, isn't it? 6,300 degrees. And it would start to look like a circle, wouldn't it? I mean, if you had 37 sides, you're getting closer and closer the more sides you have to circle-like shape. Agreed? Yeah. All right, let's do an example with a shape that you are familiar with. Home plate in baseball, whether you watch baseball or not, I know you've seen this shape before, has 3 congruent right angles. Okay, the top 2 in this picture and the bottom one. And the other 2 angles are also congruent. What is the measure of one of the other 2 congruent angles? So what are we going to do here? Total of degrees in the shape. This is a pentagon, so how would I find the number of degrees in a pentagon? Now, we've found it once before, but in general for a shape, we would do our number of sides, which was 5, minus 2 times 180 to give us how many degrees? 540. Now what are we going to do with my 540 degrees? Okay, so we're going to subtract off. Please make sure you don't write equals, equals, equals. None of these statements are equal to the next one, right? It's just a step 2 in the process. 540, and I'm going to subtract off 90 times 3, or subtract off 93 times, either way. So if I do 540 minus 90 times 3, what am I left with? 270. Good. Now what? Yes, don't put divide by 2 right here, right? Because that would make this equal signs not equal. This is like step 3. We're taking 270 and we're going to divide it by 2. 135. So the angles that are the non-90 degree angles here are each 135 degrees. Is that all right? Okay. In a regular polygon, the measure of each interior angle is 162 degrees. How many sides does the polygon have? This is like reverse of the information that we were working with, right?
Just divide by 3.
Nope, we wouldn't divide by 3. What did you have an idea of? Yeah, what were you saying, Leah?
Well,
Sorry.
I don't know exactly like how to start it, but I mean, it's that's like the ending number of the previous one. So we said to go backwards.
So you do n minus 3 times 180 equals 162.
Okay, good. So I've got n minus 2 times 180. That's how the problem began before I put any numbers in anywhere, right? And Leah's saying the way it ends is that this thing should equal the 162.
Would you like set it equal to that?
So you said it equal to that. Just exactly right. And then we're going to work this out so that we can figure out what the n value is.
Well,
So, what was that? I'm sorry.
they're saying 162 is each interior angle.
So we're missing something still. What do you think we're missing, Hannah?
Don't you have to do 162 times how many angles there would be?
Okay, I think she's right, don't you? Which is what? Times n. Why are there n angles? Yeah, and it's really because we didn't label it exactly here. We did on the slide before, is that n is the number of sides, right? N is our number of sides or our number of angles. It's, you know, the quadrilateral being 4. It's the pentagon being 5, right? So n is our number of sides. So if we take 162 and or our angles and we multiply that by the number of angles, then we'll actually be able to find the total angle measure in the triangle or the trapezoid or the quadrilateral, whatever the shape is, okay? Whatever our shape. So, now what? Okay, there's a couple of ways to start. I am going to suggest that we go ahead and distribute instead of divide. You could divide, but then you're going to deal with fractions. So if we could avoid the fractions just because we don't have to have them, that's kind of a little bit easier to work with. So I'm going to get 180 n minus 360, right? Equals 162 n. Now what? All right, we need to put the 162 and the 180 together. Okay, we can do it that way. We'll subtract the 180 degrees. That's okay, because I also have a negative 360 on the left, right? So what's my negative on the right? 18 degrees. Now what? Oh, my n, thank you. And it's negative. Okay, and then divide by the negative 18 degrees. So n is 20. And that's what I was asked to find. How many sides does the polygon have? 20. 20. Good job.
We don't have to label it sides because we already know the n stands for numbers.
Right. Yeah, I mean, you could put 20 sides down either way. It would be fine. Yeah.
So then I'm gonna ask
I don't think I
what
had
the
that. Oh, wait, there it
total
is.
angles-
I'm sorry.
If you did ask what the total of the angles was, you would have 160 times 20. right?
You would. Yeah, if you wanted the sum of the angles, right? All right, the sum of the measures of the exterior angles of a convex polygon with n sides is 360. So it doesn't matter what the shape is. If you add up all the exterior angles, which is the blue angles in this picture, they add up to 360 degrees. 360 for all of them. All right, one more example in this section. There's more than one way to do this problem. If lines A and B are parallel, find x. Any ideas?
Make it a reduced star by finding
Not complementary, but the other half of the 140 and 135.
You're thinking about the angles that are on the other side of the 135 and the 140. You could do that way. What else did you have an idea of,
Did you
Erica?
just add 135 and 140 and then subtract them from 180?
It's open.
But it's not a triangle exactly, right? It's open.
If there was like between A and B, if there was a line there, it would be a pentagon.
Okay, so there's two very viable ways, and Erica and Brianna have both hit on them. Okay, you guys did a good job. So let me do the pentagon one first, because that's the one that's actually in my notes, and then I'll show you how you can think about it with the triangles that you could create the way you were describing them. So I like this one just because we already did the pentagon, which means that we can kind of use information we already used, right? We know 540 degrees. And I can create this line however I want, so I want to create it to create 90-degree angles. How about you? Make it nice, right? So let's create 90-degree angles here. So could I use the fact that a pentagon's got 540 degrees to find the one missing angle in this picture now?
Yes.
Yeah, and that's a really nice, simple, straightforward way to do this particular problem, because we can put that line in and create a pentagon. So if we do it that way, then we are going to have 540 is going to equal all of these angles. So I've got 135 and 140 and 90 and another 90 and my missing x. So what is the sum of 135, 140, 90, and 90? 455? Then what would x be? X is 85. Okay, I like that particular method just because it seems so clean. You can create some triangles, so let me show you what would happen if I drew basically that same picture, that drawing that line straight down, but I drew it over here. Okay, pretend for a minute that that actually created two triangles. Let me move it so it does. All right, so Brianna mentioned that I could find the 135 value on the other side of this. So if I did 180 minus 135, what would I get? Say it louder. 45 is right. So here's 45. And 140 with the 180 on the bottom would give me a 50 down here, yeah? Oh, sorry, 40. Thank you. I was already wanting to do my third side. All right, these are 90-degree angles on purpose so that we can use the triangle facts that we know. Can I figure out how many angles, how many degrees go in that particular angle? Yeah. Sure. What would it be? 45. And in this one, it'd be 50. And then I have, yeah, I've got a straight angle right here, yeah? So then 45 plus 50 plus x equals 180. And x would be the same 85, but done a different direction, using triangles instead of trapezoids. Cool, right? Two ways to do the problem, both equally correct.